Okay, hi everybody, and welcome back. Today is code generation day. Woohoo! And before I forget, I'm going to come in here and tweak the fonts because I was printing, and unfortunately, Eclipse uses the exact same font for printing as it does for code. So when I first print, I get this huge text all over the paper instead of something that's smaller and less paper to deal with. Because usually what I like to do is, do the examples that I want to do before class, print out the relevant bits so I can actually walk through them in front of you. Okay, so apply that and close that. Good. Okay, so any questions on anything so far? Enjoying the enjoying the parser type stuff? It's new. I mean, it's new and different, and it's one of these things that's like, when you have a need for it, it's nice to have that kind of technology as opposed to having to write that stuff by hand, because that stuff is gross to write by hand. So what we're going to do today is a little bit more validation on the expression stuff, just to show you a couple of techniques there, and then start talking about how we can generate some code. We're going to be generating Java code. Unfortunately, I wasn't able to get things to work quite as nicely as I wanted to between the generated code here and IntelliJ, so we're just going to keep everything inside Eclipse for this next assignment. We can set up what I did at work, which is basically the completely independent Eclipse setup, and then it generates code, and that code is referred to by the projects in IntelliJ. It's just a hassle. I will leave that as an exercise for the interested reader. So let me just make sure that recording is going. That looks like it is. Good, and onward we go. So the first thing I want to do is do a little extra something with the validation. We only did validation kind of at the wee end of the class last time, just to see, is something starting with a lowercase letter? What I want to do is extend this a bit so that we can check to see, is a variable actually assigned before it's used? And so what I'm going to do here is create a new check. And I'll say variables, oops, assigned before use. I'm going to get this a little bit closer to me so I can actually, there we go. And, oh, come on. They need a little bit more room up here. This is just like awkward. I mean, it's nice for, it's like if you're using the big right-on screen, but like a normal laptop, I don't know. So variables assigned before use. And what I'm going to do is I'm going to pass in the model instead of just the variable here. What this is going to do is, if I have the model passed in, anytime the validation checker sees a model when it's walking down the tree of objects, it will call this method, passing it in. We can then use that model to take a look at everything as opposed to just looking at one variable at a time. So here we were looking at one variable at a time. I'm going to use some helper methods here, but I'm not going to annotate them with that check. And so what that's going to do for me is I can call them, and there's some recursion involved, which is why I want to use another method, or a couple other methods. But they won't be called as a top-level check from inside the validation routines. So inside here, variables defined before use, I want to keep track of a set of all the variables that I've actually been assigned as I'm walking through, and then just pass that to these helper methods so they can check to see, when I see something being assigned, put it in the set. If I see something being used, make sure it was in the set. And if not, flag it. So I'm going to start off here by saying val assigned variables. And we're going to say new set, new hash set. That's just a little method in extend. You could be a little more explicit like this. No, you can do it without the space. There's actually a method called new hash set.
No, I know. I just mean, what? Is it really that much more work than space?
Not really.
So,
And I think actually if you say new hash set, you can actually pass in values that you want to put into it. So that would be helpful.
but you're also not, if you don't pass in any values, you're not getting it.
You're not getting the type.
It's just an object.
Mm-hmm.
Set it that
Right. And depending on what you're using it for, that can be fine. Like for this example, we're just going to throw objects in and just check that an object's in it. So it doesn't really make a difference. So we've set up our assigned variables. Now what I want to do is walk through all the statements in our model and validate that each one of them is okay. So I'm just going to look at each line by line, calling some other methods to help us out. So this, yes,
Is there documentation for this for
yes,
extend?
yeah. So there's, if we take a look
Some
at,
of this is just like
oh, the language is,
mostly Java, but some of this is some
it's
stuff.
Java-ish. It's like right in between Java and Kotlin. And I wouldn't be surprised if people who wrote Kotlin liked this language because there's a lot of things in this language that are very similar in Kotlin, with one big exception that this has an advantage to. It has dynamic dispatch at runtime. We'll see some of that. But if you type in Eclipse and then extend, that's Xtend, you'll find extend, modernize Java. Ooh. And from in here, they have some pretty good documentation on this stuff. And what I'm doing with this is stream work. You've probably seen this in other languages, like in Kotlin we've used it. In Java, you can do something similar. Lambdas in extend are done with square brackets. I have no idea why. I mean, it may be that there was a conflict with the curly brace with some other construct. I haven't really looked at the language that closely to see. But inside here, you have an implicit variable it that's passed in, just like in Kotlin. And you separate your arguments using a vertical bar from the rest of the lambda. That's their syntax. I did not write this language, but that is their syntax. It's kind of like what? So Ruby's similar to this?
Yeah, I think Ruby without the square brackets, and that's just weird. You can, when you do a for each, you can separate your math things by a type.
Okay.
So it's not unheard of, but still weird.
Yeah, it is kind of weird. If you had multiple arguments being passed into a lambda, you'd have, first comma second, that type of thing. Notice how it changed to a different for each here. I'm not sure why the coloring looks different on this. I think this is an extension method. But this passes in the index of the element and the element itself. So if you wanted the index, you could use the two version of it. If you just want a single one, like it could pass in statement, I can do that. Or I'm just going to use the implicit it, since there's only one argument going to it. So in there, I'm going to say test1, assigned variables, like that. Now, where'd the it go? I'm going to use test1 as an extension function, or extension method in extend, meaning it looks like test1 is a member function of statement. And I can do that by defining him def test1, passing in the first argument of whatever the statement type is. So if I wanted to say for statements in general, let me find him down here, I could do something like that. And I also want to pass in that assigned variable. So I'm going to say assigned variables. Oops, not doing Kotlin. Set a variable, something like that. So in extend, creating extension functions is just a matter of having the type that you want to use as the receiver as the first argument. And you can either call that by saying test1 it, comma, assigned variables, or you can say it dot test1, and it takes it as a receiver. Now, by default in a lambda, it is automatically used as a receiver for everything. So you don't have to specify the it. You can just say test1. If you want to be more explicit, feel free to say it dot. Either way is fine. Or if you want to be more explicit,
We can just call test one.
yes. So this is an option here, or you can also say test1 s comma. Any of those types of options there. Okay, make some sense? I'm going to go with the implicit int and just say test1 there. So now I've got this def test1 taking a statement. Now statement is an abstract superclass here. If we take a look at the grammar, statement is just used as a superclass for addition and assignment. We're not actually going to have an instance of it. So we don't need to have an explicit method to catch statement. We can catch all the things that are going to be concrete types we're going to walk across here, which are assignment, addition, multiplication, variable reference, and literal. So I'm just going to use those. So I'm going to say assignment, and what do I want to call this? I guess I'll go ahead and spell them out. Addition, come on. Multiplication. Variable ref.
That's one thing IntelliJ seems to be better at.
Literal, what's that?
Putting the things you actually want near the top.
Depending on what you're using in Eclipse. Now this one, the code assist for extend isn't as good as the code assist for Java. The code assist for Java and Eclipse, it does that same kind of thing, and it actually gives you a percentage likelihood. And what Eclipse does is if you say, I'm willing to contribute my usage, it'll actually keep track of which things you choose most often and send those off to the common database to say, here are the most likely ones. So it's really getting real user hits. So I think Eclipse has a leg up there, although there's a privacy issue. Although you're coding, hey, you know. So let's see. So literal, variable ref, multiplication, addition, assignment. So I got all those. Now each of these functions here, when you call it, it needs to be able to resolve that at compile time. You know, just like in Java, it's going to try to pick the best match. What do we have up here as it? It's just a statement, right? So none of these actually match. So what I'd really like to do is say, let me examine that type at runtime and choose the right method. And I do that by saying dispatch in front of each of these. And note that all methods that have the same name and the same number of variables have to have that dispatch in front of it. What the dispatch indicator does in extend is it says create a separate synthetic method that will take a super type of all these guys, and then at runtime say, if it's an assignment, cast it to assignment and call test1. If it's an addition, cast it to addition and call test1. And what that extra little synthetic method does is set it up so that you can pass in anything that is a super type of these guys, and it'll be able to go and figure out the right method to call at runtime. So,
Anything that's a super type of all of them?
yes. So I'm not sure if it uses object as the super type or if it finds the first common super type. Let's just see if we said val s equals a string. Can I say test1 s.test1 assigned variables? Nope. Addition, literal, multiplication, variable ref, or assignment. So apparently, it's letting me use the super type that is statement at this point, but not any old thing. So it's not just an object it's doing it for.
Least common super type.
Possibly, unless there's other common super types. I mean, maybe it does multiple overrides. It may go the farthest up super type that's common to them all. So instead of the least common, it might be the most common. I'm not sure if least and most makes sense in this, but the highest in the tree, I think that's a common super type. Oh, you're right. So it might be the least common one, the lowest common. Let's say lowest, the lowest in the tree, the closest to the definitions of all these guys. So is there, can I take a look at the extend gen? Possibly.
I don't know. I'm just trying to come up with a word for that doesn't assume you're going in what direction you're aiming your tree.
Let's just see. Assignment, addition, multiplication, variable ref, literal. It picks statement. So here's what the code looks like that it generates. I mean, it's real straightforward. You can do the same thing by hand in Java if you wanted to, or other languages. I do wish that Kotlin had this feature where it can generate this automatically. It would be a really nice addition to this. And it goes really well with extension methods. So now I have all these guys. It's going to pick whatever the appropriate type is and call the appropriate method to take a look here. Now we got to decide what to do on each of these. When we see assignment, what do you think we want to do? We want to record that that variable was assigned. So we're just going to say assigned variables dot add assignment, whoops, dot variable, like that. And then we also have to take a look at the value side and then recurse through it to find usages. So we're going to say assignment dot test, or assignment dot value dot test assigned variables, test 1.
We want to do that first
Why is that?
because you can't use something in what gets assigned to it.
Exactly. Yeah, that was going to be my next thing. So I was about to say, what's wrong with this? So we need to check the value first to see, because if we're declaring it, you can't reference it until it's been finished being declared, or being assigned. So now these other guys here, what we really want to do for like addition and multiplication, we want to just recurse down the operators. So I'm going to say addition dot op1 dot test assigned variables. Why do I keep saying test? Why did I say test 1? I don't know why I did that. So that'll set up those two guys there. We're going to do the same kind of thing for multiplication. And then for a variable reference, here's where the fun is, right? So we're going to say if not assigned variables contains variable ref dot variable. Then I want to put up an error message. So I'm going to come up here and grab this error message code. And I'm going to say variable not defined, not assigned, variable used before assigned. And let's create a new error message type up here. These error message types just let you in Eclipse do filtering, so you can just see certain errors you care about at any given time. You could use the same type for all of them if you wanted to. It could just be expression error.
Is there an error method that doesn't take a type? So you don't have to define this stuff before.
You always have to define a category for it. Used before assigned. Used before assigned. And we'll come down here and say used before assigned. Now we need to say what to highlight in that object. That's what this literal is here for. So I can say variable ref variable. I want to actually highlight the actual variable usage. And if I remember right, there's actually a little bit of a problem with extend here. Normally when you say error, you have a choice of specifying the actual object that you want to flag with the error message. And then this tells what part of that object to highlight. If you don't specify that object, it uses the current object, whatever was passed into the function. The problem is this is not a check method, right? I'm just realizing this is not an error. It's actually, this is the way it's supposed to work. This isn't a check method. Anytime you have a check method, the variable that's passed in is kept track of as the current thing being tested. That's the default thing that will get highlighted in this error thing. Because I've recursed my way down, I'm not actually at the thing that was being tested, which in this case is the whole model. So what I need to do in here is pass in which object I want to highlight. So that's going to be the variable reference. If I said variable ref.variable, it'll actually go up to the declaration of the variable and highlight it there. I don't want to do that. I actually want to highlight it at the reference spot. So I'm going to say highlight the variable that's listed in the reference. For literals, nothing to do. So we just put that there. So the warning is that it can't figure out the type of something based on recursion. So what I need to do is on each of these methods, because it's recursive, normally what it tries to do is do type inferencing. When you have methods that do circular recursion, it can't properly do type inferencing. This will happen in Kotlin as well. So what I need to do is explicitly say the type of all these functions. So I'm going to come in here and say void, because I'm not actually returning anything. Oops. Yep, they all have to be the same definition. There we go. So now we have that. It should highlight all the errors if I have things out of whack. I think that's all I needed to do here. Let's try running this.
You said it's the name and the number of variables. That's what combines.
The name and the number of parameters. So those are all grouped together for the dispatch. If you don't have dispatch, it just does normal polymorphic lookup. So it's compile time resolution of the types, and then which place in the hierarchy at runtime. Okay, so source. Let's take a look at sample.model. That's not what I wanted. That's later. Test one the expressions. Oh, everything's tiny. Let's bump that up.
This is our inner.
This is the nested Eclipse, so it has a separate copy of these guys. And we'll put him back up to 18. There we go. That's a little bit better. So let's go ahead and move the assignment of y down, and boom. I fly over here. Variable used before assigned. Yay! Validation. Cool. Okay, and I could do the same kind of thing moving x down there, and now it's going to highlight both of them. So this makes it kind of nice for doing some simple validations at edit time as opposed to at runtime. Make sense? You can't always do all the validations you need. It depends on how much information you have about types. Depends on if you, in this case, we're just caring about a name, right? But if we wanted to do type checking, if we had enough information in our little language about what types these are, we could actually come down here and say, hey, these two types aren't valid. Like let's say y was a string. 3 times string isn't valid. Well, it could be depending on our language. Maybe we have our language concatenate itself 3 times. Who knows? Make sense so far? Okay, so that's just a little bit of extra validation I wanted to show there. A little bit more interesting. Now the fun stuff. What I want to do is I want to generate a Java class that's going to evaluate this expression. So this Java class is going to define the variables. It's going to evaluate all the expressions and then print the result at the end. I also want to have this Java class print out basically what you see up here, but with some extra parens around the expressions so we can see how the thing is actually being interpreted. So I'm going to close down my outer Eclipse because I'm going to modify the code generator right now. If you're modifying stuff inside of a code generation method, most of the time you don't need to restart the nested Eclipse. The hotspot runtime in Java will replace methods as needed. The times when it most likely won't be able to do that is if you add a new method, if you rename a method, if you change parameters on a method, or adding fields, things like that. But if you're just changing the guts of a method, usually the debugger will be able to, or usually when you run in debug mode, it'll be able to replace things. If you're not running in debug mode, it won't replace anything. So that's our validator there. Let's take a look. Underneath that expressions, there's this generator package with expression DSL generator. And inside here, he has this doGenerate method, which just says, here's the resource, which is basically the thing that contains the file we're editing. What do I want to do with it? This file system access guy is going to be used to write out a file in some directory. Now you have some control over that. If we wanted to, we could go through and define a bunch of different types of output directories. So for example, what I do at work is I have a little model generator that generates Java classes. It generates forms in Android. It generates enumeration, generates factories, a couple other types of things it generates. I'm blanking on it. Oh, it generates a dot file for GraphViz to show the class hierarchy. By doing that, you can actually, there's another thing you can set up to say, here are my output directories for certain types. And then in your code generator, just logically refer to, this is a dot output, this is Java output, this is a form XML output. And then it'll map it to the right directories. Also by doing that, it gives the choice for the generated IDE to let the user in the preferences choose for those different types where they go. Okay, but we're not going to get down to that level of detail. It's just something you can do. We're just going to have everything generated to the default directory, which is source-gen in the project. So what I'm going to do to start with, I'm going to uncomment this. I'm going to use the FSA generate file and say what file I want to generate here. Let's call it sample1.java. Note that I'm not qualifying that with any type of package directory. This is going to go to the root of source gen, so it's a default package. In general, really bad idea in Java. You don't want to use the default package for things. For this example, it'll work just fine. And then over here, I want to say, what code do I want to generate here? So I'm going to say, what did I do with this one? Let's take our resource, all contents, which is going to be a list of things. In our model, we have a single top-level object called model, right? So I'm just going to say, give me the first thing in that list, because there's only going to be one thing in the list. I'm going to cast it to model. And then I'm going to call gen class. Kind of like that. So that's our kind of top level thing. Let's take a look at what gen class is going to do. So I'm going to say def gen class, passing in a model. And what I want to have this thing do is generate a string. This argument here is going to be a string that's going to be written to that file. I can say return some string in here if I wanted to. Notice the type inferencing fixed that all up. Or I can use a shortcut. If all I'm doing in here is a template, I can have this entire method be a template by using triple single quotes. And then everything inside there is going to be template language. Now, if I want to do some prep before I actually started generating my template, I could put that all inside of a curly brace and do my prep as normal extend code, and then reference it inside that that template. Okay. A lot of the times, all you're going to need is to put that little template in like that. Okay. So when we're generating a class, I don't have a package in there. I was looking, I'm like, that doesn't look right. I'm going to say this is going to be public class. And in this case, I'm going to hard code the name of the class because I don't have any information in the class for that. And inside there, public static void main, string, bracket, bracket args, something like that. And then inside here is where I'm actually going to do the interesting stuff. What I'm going to do is for every expression that I run, I'm going to assign it to a variable called result. I should probably use some special character in there because our variables, let's see, what do our variables look like in this? Just letters, right? Letters and numbers, maybe? So it's, is it just ID? So we're using ID, the default rule for that. If I take a look at what he looks like, he allows letters, underscores, numbers, things like that. So I may want to use a character that's not a valid ID character. That little caret, by the way, allows you to, in Xtext, override something that's a keyword in the language. So if you wanted to use a variable called for, you could say caret for, and that works just fine. FOR. In this definition here, when you're generating code, one of the things you want to be really, really careful about is potential conflicts with what the user can enter. The user can enter any of that for an ID. So we need to either come up with, need to come up with a different rule to restrict what they can edit, or find something that's valid that the user can't edit. Any suggestions? If I want to have a variable called result and don't want a conflict if the user happens to define a variable called result. Java is our target language. So what might be a valid character in Java for an identifier that's not in this list? How about our friend the $? So $sign is actually a valid character in Java for identifier, but it's not in this list of things here. So what I'm going to do in my generator is say int $result equals 0. We'll just start with that. And then I'm actually going to start doing my evaluations. The first thing I want to do is define all my variables. So I'm going to walk through the list of the variables in the model and write out declarations for them. I'm going to use my little Guillemot sucker here by doing Control Shift less than. And that gives me the little double brackets. And inside there, I'm going to say 4 has to be uppercase. Let's see. Variable in model dot variables. And I'm going to close that with an end 4. Inside there, I'm going to say int, then use my guillemots to say v.name equals 0. Now, our validator makes sure that variables are assigned before they're used, but it doesn't. I'm trying to talk myself out of this. It makes sure that variables are assigned before they're used, which means that we really don't need that initializer on here because it's going to be assigned before it's used. That's our validation. So I can just go ahead and get rid of that and just define the variable. Boom. Now what I want to do is walk through all of the statements. And what I'm going to do here is say $result equals, and then do the statement over here. I'm just going to say s.gen. So it's going to be, I'm going to generate whatever code I need for that statement. And then at the end of this, I'm going to say system.out.println $result. Just like that. And just to start, just to see if we actually have something that's almost working here, I'm going to create a little gen for statement that's just going to print out a 0. That's all it's going to return. So I'm going to say def gen statement. Oh, come on. Is just going to, I can do this a couple different ways. I could say return 0 like that, which is a little bit more efficient than using the templating there, but not that much. I mean, with the templating, it has to actually scan through it and figure out if there's any variable definitions or any guillemots. You can do it either way. It's a little bit more efficient to just return the value. Okay, so now everything's compiling okay. Let's go ahead and give this a run. I'm going to go into my nested Eclipse. Note that I'm going to have to kill my nested Eclipse and come back in several times during this because I'm going to be adding new methods. So here's my test expression. I'm going to just add a space, delete a space, and then save it. And let's see what we got over here. Sample 1. Oh, I called it sample 1 over here, but not sample 1 here. I'm not going to get out of this nested Eclipse. I'm going to go back to the external Eclipse. I'm just going to change this to be sample 1 and save it. Come back over here. Let's put him over there. Save it. Boom. And now everything is peachy. Yay! So far so good, right? Let's close this nested Eclipse. And inside here, get to work on the actual, what we want this stuff to do. So once again, I'm going to have methods for each of those expression types. I'm going to go over to my validator and just copy all these guys just to save myself a little bit of work. Paste them down in here. I'm going to call these all gen. Going to make these be strings. And this is something I really miss in IntelliJ, Control-Shift-O, giving me this little wonderful dialog to say, hey, I want to get imports for everything that's undefined. Which one do you mean? So I'm going to pick that assignment, and then boom, you see all the imports worked out just fine. Yay! So now we've got to actually do the generation on these guys. I don't need that statement anymore. So for generating an assignment, what I want to do is say variable name equals the value. So this guy is going to become assignment dot variable, whoops, dot name equals assignment dot value dot gen. Just like that. And so you can recursively go down and figure out how to generate assignment value gen. Note that I'm not going to throw a semicolon in at this level. I'm going to take the semicolon and put them up here when I'm doing statements. So once the full statement is generated, I'm throwing the semicolon on it. So then down here, for generating addition, it's an extension function. Yeah, I'm using it as an extension function. So I'm going to say addition, oops, Gmats, addition dot op1 dot gen, addition dot op, and addition dot op2 dot gen. Exactly. Okay, and then this one's going to be almost the same. Except he's going to be with multiplication. And then the variable reference is just going to be variable ref dot variable dot name. Literal is just going to be literal dot value, just like that. And so that should give us some nice code generation for these guys. Let's also dump everything out. So what I'm going to do is create a copy of all these guys, calling them dump. And one thing about precedence you want to be careful of here. Right now, when I'm generating all those expressions, I'm assuming that the precedence of my little language matches the precedence of Java. That might not be the case. So what I might want to do is be very explicit about my precedence when I'm generating the Java code. My rules define precedence explicitly. What I can do inside here now is just around this addition guy, throw in parentheses. Kind of like that. And variable ref here. No, we don't really need it around a variable ref. It's just a variable. Something like that. And I'm going to do the same kind of thing down here. And so dump variable ref, dump assignments. These guys I just got to change to reference dump. This one's not terribly interesting because they look pretty much the same. The difference is going to be there's no semicolons on the end there. The one big difference in our language is the definition of a variable. So when I'm dumping up here for what I want my variables to look like, I'm going to print it out as var and then the name as opposed to int in the name. So what we'll do here is just do a system.out.println. And then inside there, v.name with a var in front of it. I could generate a separate method to dump that guy. I'm just not going to bother up there. And then for each statement, I'm going to print out s.dump. Kind of like that. And I could have, since these actually are looking exactly the same, I could have just referenced the gen inside the print up here. Yeah, let's just do that. Why not? Is there anything that's different? No, nothing's going to be different.
So you're just printing out what we're going to get in the
I'm actually trying to print out what the original stuff was more logically. So because I'm basically printing out the tree, this might not be exactly what the input looked like because of the inferred precedence, but it's going to print out, logically, here's what my tree looks like. Okay, so let's go ahead and run this. Save it. Boom. We'll see that we have a bunch of other stuff printed out here. Everything looks okay. Let's go ahead and run it and see if it actually going to run. Oops, it's in my source gen. Let me
Trying
get rid
to
of
put the print lines in the generated Java class, or actually print them.
when you run the application. So so it's going to print out what was done and then print the result at the end. So let's say run.
For some reason, I was thinking that's not what we're doing.
There we go. So now we see that it printed out the variables, it printed out the assignment, it printed out the expression with the extra parentheses so we know explicitly what our precedence is, and then the result. Ta-da! So that is an example of code generation. We've now taken our little custom language, generated Java code to actually execute it. Now that's a lot simpler than that evaluator was, right? The evaluator is quite a bit more work. What's the advantage and disadvantage of these two different ways? Why would I ever want to do the evaluator approach?
If you didn't want to have to really do some another language on your user, like you just wanted it to run in the context of the exponent grammar.
So actually one thing is if you wanted actually the grammar to run it, you could do that directly. How about when can you modify the expressions, this expressions file? In either case. So if in the evaluator, or let's say in this version, anytime I edit that expressions file, what happens?
Well, you would have to regenerate the code.
I'd have to regenerate the code and
They can become out of sync.
deliver a new application, right?
Wait, you mean this like the file that you're reading?
So this file right here,
Yeah.
if I wanted to make a change to that, if I'm using this approach, that's going to generate code,
Oh, right.
which means in order for the user to get something different, I have to deliver a new copy of the generated code, right? And if they're using the code as part of other code, we could deliver this as a library and they compile it. If they're just using it as an application, I could generate this as an application and just hand them the new application, right? With the evaluator approach, what happens there?
This code doesn't change.
The underlying code doesn't change. So at runtime,
So you just hand them a new expression.
I could hand them a new expressions file, yeah. So there's a trade-off there, right? The evaluator one is a lot more work for us to create. Now this would have been a lot more work if we didn't have some great tooling to do this for us automatically. The evaluator one is much more work for you to create, but you get that added bonus of you don't have to redeliver a new app every time you want to change new data. That's huge. You could even have a file like this sitting on a server somewhere and have the application download it. And then maybe every month you send a different file out to the server. They have the same application that downloads it each time and then evaluates it. So there is really the key advantage of an interpreter versus what we're doing here, which is a compiler. We're taking this, which is a slightly higher level language, generating a lower level language, which in turn ends up, you could argue this is just a translator. I tend to think of it as a compiler because we're moving to a lower level language. That lower level language gets compiled down into bytecode, which actually runs natively. So there's some big trade-offs there. Depending on how often you're going to change the data really drives a lot of this. So one of the main apps I'm working on, I have a form definition language for Android that generates the XML for the forms, generates some binding classes for it so that it'll automatically hook everything up to the model and make sure that you have two-way updates and everything like that. And that, I do it all statically. So at compile time, it generates all those forms. That means that anytime somebody wants a change, like, oh, I want a new field, I've got to go and edit the code, regenerate a new APK for them. That's the application package in Android. And then deliver it to them. Versus if I go on the more dynamic route, which is when I first did it, I did it dynamically. I could just pop a new set of forms on the server, and then boom, it would have those forms automatically updated. The problem with the dynamic approach, was that because the data could be changing as well as the form, I didn't have any actual Java classes representing those objects, which means that any of the code I wrote that tries to do interesting things like, hey, when you add this type, I'm automatically adding X, Y, and Z to it, I had to do very, very dynamically, almost reflectively. Basically taking a look and saying, hey, I have this general object that just has a map with fields in it. And then set this field, do a bunch of casting. I mean, the code was a big pain in the butt. So I decided to go with a more static approach. Sometimes I regret that because it's a little bit more work for me to actually change things and get out the door. But it's really going to depend on, once this thing gets kind of finalized, how steady the forms are. Okay, questions so far?
Like this particular example, right? It's almost like we're writing a program for our data. So this doesn't make nearly as much sense as the value.
So the question is that this type of program is basically we're just writing another representation of our program. It depends. So if you think of a tool, like let's say we were writing an analysis tool for some people who want to do some data analysis. We might write them a little language like this, which is going to simplify their definition of their data, deliver the application to them once, and then they can just keep tweaking this dynamically and rerun new analyses against their data. That might be very useful to them without having to go through this full build and compile process, and without having to come back to us to generate it.
So that's what I meant. Sorry.
Oh, okay.
The evaluator one for this particular grammar, right, makes more sense.
Mm-hmm.
Because we're defining,
I mean, depending on what we want to do with this.
defining a program, right? Like it seems like you'd want to be able to not have to regenerate that every time. I don't know.
Yeah, I mean, well, it depends on what you're trying to do. I mean, if this is meant as an assist for you as a developer to make your life easier, which this one really doesn't do. I mean, I could just as easily have written this right in Java, right? But if it's meant for a third party to be able to simplify, create a very simple language that they can dynamically update, the evaluator is definitely the way to go. Okay, so that is him. Let's do a more interesting example. I want to generate a model. Let me go ahead and close my nested Eclipse. And out in my external Eclipse, I'm going to create a new project, xtext project. I'm going to call this javadude. What did I call it? Model. Okay, so I have the name of the little language is model DSL. The extensions for the file is model. I'm going to turn off my testing support because I just want one less thing. Allow Gradle, allow build language server, and finish. So now we've got a new little language here. What I want to do is allow us to define some classes. And the classes are going to have properties in them. And I want to generate all the Java Bean stuff for it. So the field for it, the getter, and the setter. I'm going to have the getter and the setter just do very, very straightforward things. It's like you can pass the value in, you can get the value out. And I'll let you have lists as well. But you have to pass the list in and get the list out. So let's start this by saying at the top level of a model, I'm going to have a package keyword followed by a package definition. Now what I'd like to do is that package definition have to be a qualified ID, so something dot something dot something. You can create a special kind of rule in Xtext that allows you to take tokens and just create a synthetic token out of it. So I'm going to start with an ID, possibly followed by any, dot followed by another ID. Repeat, repeat, repeat. And this treats it as a token as opposed to an actual object that has all this stuff inside it. So if all you're doing is having terminals listed inside there, it creates this little synthetic token for you. So package will end up being just a string. Then I'm going to have my classes. And I'm going to learn from past mistakes and say class decal instead of class there. In my original version of this, I used the word class. And I constantly, like, Java lang class is a thing, so I constantly have to fully qualify everything all over the place. And in that same generator, I'm sometimes needing to reference Java lang class, so I've got to fully qualify all over the place. Save yourself some trouble. Make up a name that doesn't clash if you can.
Java uses like class with a K internally when we do stuff like that, or class with two
Or
Z's.
class with two Z's, yeah. In Kotlin, it's class with a K. Typically, when you see people, and you're going to see me do it in here, when I type in a variable name, I'm going to say class, C-L-A-Z-Z. That's the most common variable name for a class because it clashes with Java. Okay, so a class decal is going to be the word class followed by a name, and we'll give it a curly brace. Now, in my little language, I'm not going to have any semicolons because I hate semicolons. It's useful once in a while. Like in Kotlin, there's a few places where it would have been really nice to have that semicolon. Unfortunately, they have to actually rely on white space or new lines in some spots, and there's a few spots where you have to have things on the same line. I think we saw that when we were doing extension methods earlier. We had the infix ones, and you had to have it on the same line. You couldn't have it on a separate line. So there's our class. And then I'm going to say properties plus equals property decal. And when I was working on this previous example, I actually just said property, but there is a property in Java that gets in the way there. So I'm going to have him in there. And a property decal. Come on, fingers. He is going to be, we could use a keyword there, property, if we wanted to. For this little language, we don't really need it. We can just say name : type or type space name. I'm going to go with the more Kotlin-y version and say name : type. I'm going to say name equals ID, colon, and then type equals some kind of type. Now types are either going to be an int type or a string type or a list type or a ref type. So I'm just going to be very explicit on the types that I have there. Keep in mind that this means that type is just a superclass for int type, string type, list type, and ref type. Okay. We're not going to actually have a type object that we deal with. Now what about int type? Int type is just going to be int. I don't really need any properties here. I don't need to say type equals int there because that's the only possibility. If the thing is an int type, I know it's int. So I can just define it like that. We're going to see a little error about that in a minute. String type, I'm going to say string with a lowercase s just to be different. List type is going to be list of and then some base type. And then ref type is going to be ref equals a reference to a type. Something like that. Okay, and I think that is, well, actually, no, not a reference to type, a reference to a class decal. Because you don't need a reference unless it's a class decal. Now there's a little warning up here. Type may be consumed without object instantiation. Add an action to ensure object creation. So it says, for example, curly brace type. Now what it's saying here is that when I come in here, type is a supertype of list type. List says base type equals something. So as soon as you define a property, it creates an instance of that type. Note that I haven't defined properties for int type and string type. So it doesn't know if I actually want to create those objects or not. Ref type has a property name, therefore it's going to create an instance of ref type. When it comes back up to type, it says, well, here's two things that are creating objects. Here's two things that don't say they're creating objects. What do I do? So we need to explicitly say, if I see int, really create an instance of int type. I'm not going to store any data in it. I just want an instance of the object. So I'm going to say curly brace int type, curly brace. If you remember back when we did the addition and stuff, we had the addition.left equals current. We're not using the dot syntax. We're just creating an instance of this guy and not assigning any data to it. Do the same thing for string type, and now type is happy. So we're creating an instance of that object even though we're not stuffing any data inside of it. I could also have said type equals string inside there, but there's no need for that. Make sense so far? So here's a nice little language that defines a little model that I want to work with. Let's do some code generation. This first approach here, we're going to keep doing code generation the way we've done it so far, textually. I'm going to do a second example of this where, well, actually a third example, where we're going to use type inferencing and xtext, which is some really cool stuff. But we're going to start off with doing this by text, because this is actually really simple to do. And doing it by text, the build in Gradle seems to work. Doing it through the inferencing, there's some problems getting things on the class path appropriately because it needs to look at generated Java types. So there's that guy. Let's go ahead and generate that grammar. Oh, that's the wrong one. Which one is this model? So I'm going to say run as MWE2 workflow. Let it generate. And boom, so now we got a bunch of other stuff. Let's take a look at our generator. Well, before we do that, let's go ahead and our nested one and make sure that we can have a little language that looks right. So nested Eclipse. And inside here, I have this model file. Yeah, it looks like that actually, oh, almost. Oh, did I not have it? I didn't have a star there. Yeah. Junior, I'm going to get my head lopped off in this movie. Highlander was a great movie, wasn't it? Let's go ahead and run this again. Every time I see Clancy Brown, I always think the Kurgan. I just cannot get that out of my head. I'm going right over people's heads here. Huh? Have you guys seen Highlander? If you haven't seen Highlander, that's a great movie. It's a good movie. Yeah, but the bad guy in that, he shows up as kind of usually this government secret ops bad guy type. I mean, they cast him. He's always like the bad guy. Anytime you see him in a TV show, you're like, yep, he did it. I love it when they flip that around sometimes. Okay, so I generated that. Let's come up here.
Could you change the run config to run the generation for you before it launched it?
No, I actually ran it.
I know, but could you do that?
You can, if you really wanted to, you could come in here and right-click on the project and go to Properties, go to Builders, and then add in a new builder that you set it up to run that program. I don't recommend that because it takes a while. And if you come in here and you're making a little change, my habit is, type a little bit, save, type a little bit, save, type a little bit, save. And if this was automatically running, it would be brutal, which is why they did it as a separate thing. Okay, so now we have our nested guy and everything seems to be okay there. So I have a real simple little model I defined. I gave it a package name at the top. Person has a name, age, list of strings for nicknames, list of persons for friends, an address, and boom, there's the address. Okay, so real simple little model. I'm going to go ahead and close my nested Eclipse because I'm going to work on adding new methods in my generator. And here's my generator. And let's uncomment that. And what I want to do to start with is let's go ahead and grab that model. I'm going to keep track of the model as a field here just so I can reference it without having to pass it all over the place. So I'm going to say var model, model. And then down here, model equals resource.allcontents.head as model. And first of all, the file name. I need to fully qualify this guy to put that package in there appropriately. So I'm going to use my triple single quotes. And inside there, I'm going to say model.package. And this actually needs to be a file path. So I'm going to need to do a replace dot with slash. Dot, whatever the class name that I'm working on here. So it'll be class.name. Which means I'm actually going to need to say for each class. So model.classes for each. Generate file. And I will say class.gen. Something like that. And now we'll say def gen class decal I should have just used class decal instead of class there, right? And inside here, the first thing I need is that package definition. So package model.package. I'm going to need to add in an import for java.util.list. We'll need him later. And then I'm going to have public class decal.name. And if I wanted to, I could set up my model to have super types and interfaces and things like that. I'm just not bothering for this example. And then inside here, I need to define all those fields and all those the methods to go with it. So I'm going to say for property in class decal.properties and for we'll gen the stuff for a property there. Okay, so far so good. So what do we need to generate for a property? We're going to need a field, we're going to need a getter, we're going to need a setter. So we're going to start off with our field there. Private property decal dot. Now I need to transfer its type into the appropriate Java type. So I'm going to create a helper method to do that. Type dot Java type. And then the name of this guy. Property decal.name. Semicolon. We'll hold off on the Java. Well, let's go ahead and just do that now. Why not? Def Java type. Passing in. What do we have for types? Int type, string type, list type, and ref type. I need to make this dispatch because at the top level, all I know is to type. For these two guys, the gen class decal and the gen property decal, I know what type it is, so I don't need to make those dispatch. I could if I wanted to, but we don't need to there. So we have Java type for int type, string type, list type, and was it ref type? Is that right? Okay, so the Java type for an int is int. Exciting, huh? String, we're going to go with uppercase S for string. List type is going to be list, bracket, and then we have to resolve the base type. So inside there we will say type.basetype.java type. And then for the ref type, it's just going to be the name of the type. Type.ref.name. There we go. Oh, recursive stuff because of this list here, so we have to explicitly specify the type, the return type. There we go. So far, so good. So that should give us the property definitions. Let's go ahead and see what this looks like when we run it. So save him. And under source gen, we now have an A.B package, which has, oops, that's interesting. That's very odd. What did I do? What the?
There's no, you need a slash.
Oh, a slash. Yeah, duh. Okay. Wow, that was silly. I'm not restarting that nested Eclipse. I'm just changing the guts of that method. Oh, yeah, I should. Let's do that. .java. This is one thing I like about the hotspot stuff with Java is you can tweak this and get the change right away. So a.b.c, address.java. There we go. Person.java. Let's move these over here. Actually, I'm just going to put that up in this guy here. That's something I miss in IntelliJ as well, being able to just drag to rearrange windows. Okay, so far so good. Looks good, right? Let's come back out here and we'll do our getter and setter method. So public void set. And what we want to do is take that property name and uppercase the first letter. So I'm going to say property decal.name to first upper. They decided, hey, that's a really common operation when you're doing code generation, and to first lower, the same type of thing. So they just provided a couple extension methods for you that make life a little easier. Okay, and then we're going to say property decal.type.java type. And you know, I'm going to have to say that property decal type Java type over and over again, so let's just do a little variable for it. So I'm going to say var type equals property decal.type.java type. And then I can just say type here. And then property decal.name over there. And inside here, I'm going to say this dot property decal.name equals property decal.name. And then public type get property decal.name dot to first upper. Return property decal.name. I think that should be good. Let's swap back over and try them. Boom. And there we go. We have a nice little class there with Java Bean properties. Now, if you only have 2 classes in your model, this doesn't really buy you much, right? But think about a more realistic situation where you have 30, 40 classes in your model. This can save you quite a bit of typing and potentially cut and paste errors, right? This type of stuff over here is really prone to cut and paste errors. But where it really shines is after that first set of generation. So later on, if you decide, I want to do something a little different, I want to have some logging happen in every single one of these methods. I want to set it up so that I have the properties be bound in Java Beans. I can add that into the code generator, and then boom, I get it consistently across my entire model. When I was working on this current project, and I first joined, the guy who was doing the code to start with was writing all his models by hand, and he had about 30, 40 classes. And when I saw him sitting there and saying, oh, I want to make a change, and then going to every single class and making the same change, I said to him, dude, you're killing me. So I wrote him up a code generator like this. And at first, he looks at it, he's like, well, why should I define this? That's harder for me to maintain. Until he said, can you change it to generate something different? And then the light bulb went off over his head. And he's like, oh my God, I don't have to go and do shotgun surgery across all my model. I can change 2 lines in my code generator and boom, ton of things, and it's crazy consistent. So let's say I wanted to make these be Java Bean bound properties. These are properties that you can observe for property changes. So I'm going to go inside here. I think it's in Java Beans. And then inside my class, I'm going to say private Really? There we go. Yeah, that's right. Okay. And then down in here, in my setter, I can say type old value equals property decal.name, and then we'll say PCS dot fire property change property decal.name old value property decal.name, something like that. I think that's all I need. Oh, I need to delegate to him. So public. Thank you so much. That's so helpful. Let me do this. Sometimes it's helpful to write up a little dummy Java class and then copy some stuff into your template just to make sure you're getting the code right. What I'm doing this for here is I need to delegate the add property change listener, remove property change listener, and I just want to make sure I get the syntax and everything right. So generate delegate methods for PCS. I'll do those guys and those guys. And so I need the listener. And oops, all of these. Now one thing, you notice how the highlighting is set up there? The highlighted stuff is showing you what's going to actually be generated. So you'll see that this is saying it's got leading indentation in it. Xtext is fairly smart about it. Every once in a while it won't do it right. But if I just indent these guys like they should be, we'll see that it's actually showing you what the proper indentation is going to be. So instead of having all this extra space at the beginning of it, it's actually saying, well, the real code that he's typing in starts there. So that's going to be my outer margin, and then I just indent. So that little highlighting of the kind of shadowing really helps a lot, so you can kind of visualize what's getting generated there. And you see what that ended up doing? It now says there's a single space, and then the property generation stuff goes in there.
Ultimately, do you really care? It looks like
Well, I mean,
it's been generated.
it's a lot easier to debug. Because this, keep in mind, this is going to be code that's going to be running, and you can debug it. It's a lot easier to debug if it's readable code. But if you want to, you can just say, put everything in column 1 if you really wanted to. I wouldn't advise it, though.
You want to read this too, obviously. So
Yes.
doing the indentation here is already
And then the indentation in the generated code makes it a little bit easier, too. Okay, so now I've got those. Let's come over here. Regenerate. Oh, I love it when it compiles clean. That looks good. Now let's test this out. So I'm going to say, give me a person. And I'll say person.add property change listener new. Oops. Don't worry, I'll switch it to a lambda in a second. It's just usually easier for me to do this and then use the support to change it back. And then I can just say okay, so there we got that, and then let's set some properties in it. So we'll say person dot set name, Scott, set age, and let's try running him. Did I run the right thing? Yeah. So let's see, did I have this thing set up right here? Oh, see the problem? Fire property change will only actually fire if the value's changed, and I'm actually assigning it to the parameter, not the field. So that, so old one equals this dot. And then we can come back over here. See, this is another one advantages here. You fix it in one place, boom, every single one of those methods. And now we'll run this again, and it'll work. Ta-da! Yay! How's that? Neat stuff, huh? Okay, now, that's our basic test generation. Let's do one more little thing before break. I don't like to type, especially stuff like that. I like to have nice little helpers, whether it's a constructor, whether it's a factory method, something so that, especially if I wanted to set this up to have all of his friends and everything listed, this is going to be this long blob of code. Now, you remember the approach that we showed earlier on with the builders where we had that nested arguments? We can generate that. So we've got all the information we need. We can generate it. We can also generate a toString if we wanted to. So let's add those in here. So inside this class, I'm going to have a public string toString. And inside there, I can say return class decal.name square bracket plus param string plus square bracket. And then we can define a public string param string. Just going to return, actually let's use a string builder here. We're going to say for each property, we want to have the property name in quotes. So we'll say string builder, whoops, actually just sb dot append the actual name equals, and then we will append in the value. And we need to separate them with something, with commas, for example. What I'm going to do on this for is add in a separator option with a comma. So between each of those things that it generates, it's going to put a comma. Oh, I'm sorry, not just a comma. That wouldn't help us. We need to actually have a SB append a comma. So we'll say, I'm going to use a single quote here so that I can have double quotes inside of it. And say sb.append Or I could go the other way because actually it's a single character, right? So we'll do double quote with a single quotes inside. Decisions, decisions. What's that?
You just want a space with your comma.
If I wanted a space with my comma, then I want to go the other way. So let's put a space with a comma, just to give you grief. You suggested it, I'm going to do it. Comma space. There. Happy now? Okay. So that will, in between each one, put that comma. It won't put it at the end or at the beginning. If you wanted to, you could also have a before and after to say what to do at the front, what to do at the end. What's the advantage of this param string? Why didn't I just put that in toString to start with? Let me generate the code so you can see what it looks like. Let's why would I separate that into two methods?
It gives you the flexibility to have separate statements.
That's not quite why I'm doing it. Let's think about subclasses for a minute. If I defined a subclass of person, what would I want to see in my toString? I want to see parent class properties as well. So what would I define in that subclass? Mm-hmm. And then I'd call super, I'd concatenate super param string. Well, I would define a param string that calls the superclass param string to append his properties as well. Okay. There's one little glitch in the way that I've written this to allow this to work really nicely. The class name is hard-coded. How can I get around that? I can say get class dot get name. So instead of having this guy explicitly say the class declare, I'm going to say get class dot get simple name because I don't want it to be fully qualified. Whoops. And then I have that. And so now that's all spit out. Let's just make sure this works. Let's go to my little tester and have it do a print of person. Boom, and there we go. So that seemed to come out just fine. Make sense? Okay, so now let's go ahead and generate the factory stuff. So I'm going to do at the top level here. This is generating classes for each of the individual objects. I'm going to now say, and I'm going to make a bad assumption here. Okay, notice that it's barking at me here. Sometimes internally in a method it'll bark. It just depends on how extend is actually generating its code. So I'm going to have to go out of my nested Eclipse. I'm going to make a bad assumption here. I'm going to assume that nobody has generated a class called factory, so that I can just create a class called factory that you can use as your factory. If I want to make sure somebody doesn't generate a class called factory, what can I do? Oh, I could just use $factory. That's a good idea. I could just do that. Now, normally with class names, you don't want to use a $sign because under the covers, Java uses that for inner classes as a separator. But it's just you can do it if you want to. The other thing you could do is set up a validation that just says thou shalt not have a class called factory. And then user can have everything they want except factory. Although that actually wouldn't work because they can put a caret in front of it. Actually, no, it'll still treat it as the name factory. So we could guard against it that way, but I'm not going to bother. So here I'm going to use that same package, and I'm going to call this factory.java. And we'll say model gen factory. I need the entire model to look at to do this. So let's say gen factory taking in a model. It's in the same package. Do I need these? I don't need these guys. And what I'm going to do is have the factory just generate a bunch of static methods, and then you can use a static import to get access to those methods easily. You could explicitly just say factory dot for each of them, but I'll just use a static import for this example. In general, I hate static imports. So inside here, let's gut most of that. And I'm going to say for each class in model.classes, I'm going to have a public static method, and it's going to return the actual type, so c.name, and I'm going to say c.name to first lower as the method name. And what I want to do is say for each property in there, generate an argument coming in, and then also do the set inside the guts. So let's actually indent this a little bit here. So here we're going to have the argument is going to be p.type.javatype, and then p.name. We're going to need to separate them with commas. I'll use the space since it's so important to you. And then down here, we'll actually do the setters. Well, that means I need to create an instance of the object, right? So let's do that first. So let's say c.name. Sorry? Not. Oh, you're right. Down here. Good call. That would have been awkward. Would have been real obvious in the generated code. It's like, oh yeah, that was a bad place to put that. And then we'll say c.name dot to first lower as the variable equals new c.name. And then we'll say return c.name. And then inside here we can say c.name dot set p.name dot to first upper, passing in p.name. Oh, yes. And at the end as well. Okay, I think that's good. Okay, not a whole lot of code here, right? But watch what this does for me. I'm going to go ahead and run the nested guy. And let's take a look at the source gen ABC factory. And now we see that it compiled for, I love it when it compiles the first time. Thank you for catching that. So now we have all our arguments. It generates the person, puts everything in the right place. So now what I can do is in my test, instead of doing him this way, well, I'll get the property change listener dealing with it there. Let me just create a separate one here. I really just want to do this later, so we'll do it this way. So say person equals person from, actually, import static a.b.c.factory dot star. Ugh. It just goes against everything I believe in. Because I'm half tempted to just say screw it and just write factory dot in front of each one of these ones. But damn it, I'm going to persist and do it the bad way. So name, age. What are the arguments to this guy?
Nicknames, friends, and address.
So name, age, nicknames, friends, and address. Okay, so nicknames is next. So I need some way to create a list. Let's create a little helper method up here. Private static list of. We'll put a generic on him, and we'll say t dot dot items return arrays dot list as list items. Why does he not like there? Oh, I didn't give a return type. List t. There we go. And of course we get our wonderful heap pollution thing coming out of here because of the way it does type erasure with arrays and everything. Most of the time I just ignore that or add in the save var args to say I know what I'm doing. Trust me. The Java compiler is much more trusting than the Kotlin compiler. So I'm going to create my person. Now I'm going to have a list of nicknames. And then I'm going to have a list of, is this friends is the next one? And then I'm going to have a list of, oh, just an address, okay. And close off the person. And now these nested people I have to deal with. I don't really have any nicknames for her. And let's say she has no friends.
Maybe we should generate ones with all the optional ones like Kotlin might give you.
All the optional ones.
Sorry, with factory methods with just 1, 2, 3, 4 arguments.
Oh yeah. Yeah, I mean the that's actually something I did for. There's a set of annotation processor I wrote, and it lets you put in default arg annotations, and what it did was generate extra copies of those in a superclass that was the normal permutations of them all. Let's do that. Do I want to bother? To do this right, the right way to do it would be to add something to the language to say if something's optional or required, and then the ones that are required you have to specify. The ones that are optional, then it'll cycle through and stick them all in the end. I'm not going to bother with that for right now. It's an exercise for the interested reader. How about that? So we have her doing all that, and then she needs an address. What the? I'm not a fan of this keyboard. There we go, that's better. And then the city, it's Herndon. State, Virginia. And then I will say I'll give him Mike, make him 82, why not? List of address A, B, C. Get bored after a while, and is that? Oh, geez. I'm like, what the heck did I do? There we go. And am I missing a paren somewhere here? Oh, kill that. There we go. And then if I came in here and said person.setName, I'll get that property change report. And so now I can say, this is test 1. Yeah, okay. Run as Java application. Really? What did it do? That looks right. What the? That's just weird. I don't know why that didn't print it out before. I was running the right thing, wasn't I? Oh well. Huh. Yeah, third time is a validation here. Huh. That's what it should have done the first time. Okay. So we can see that now it's filled in all the data, and that saved us a ton of work if we wanted to have that kind of a thing generated for us. And as John mentioned, we could have it generate all the overloads of that method with different parameters to simulate the default parameters on the end of the list. Okay, make sense? Yeah, I had for the project I'm working on, I had it generating constructors like that where it would have everything be optional. You could specify what you wanted. Eventually I said, I don't need that because I was actually using a third thing to do the generation for me. Okay. That's that one there. Let's go ahead and take a... Yeah, let's go ahead and take a quick break. I don't have a whole lot left, but I got this and then talking about the assignment, which I haven't written up yet. So let's say we'll say 20 after. We'll take a little bit more than 5 minutes. Okay, so just as a really basic code generation, what we're going to do is take this greetings example. This is what comes when you first install first create an Xtext project. I just created one with the default name, just as an example here. So the greetings will be hello name, and so on. In the generator, what it's generating right now is just a comma-separated list of people that we've greeted. Let's have it generate just a real simple class with a main that just prints out the people's names. So we'll do it a couple different ways here. Let's say greetings.java, and then we'll say, let's just do it online here. Why not? So I'm going to have public class greetings, and then public static void main string args. And let's print it out a couple different ways. Let's print out first one per line, just so we can see how that happens. In order to do one per line, what we're going to have to do is either outside of here concatenate things together, or use the for box that I was using that, or use, I believe, join would work. It'd be a little awkward, but the join should work. Let's do it 3 different ways here. So we'll say for name in, let's do this up here first. Let's first of all just get our model. So say val greeting equals resource all contents filter greeting head. We can do that if you want to. Oh, that's just pulling out all the individual greetings. Yeah, let's just do that. Why not? So that's going to give us a list of the greetings to start with. And then once we have that, I'm going to say for each greeting in... Why do I keep hitting that? End for. So this is one way we can cycle through them all. Okay, so we can either do that or why didn't it take an iterable? That's weird. I would have thought that would have worked with just an iterable. So I said, go ahead and give me all the elements that are just greetings. So it's going to walk through that list of all the contents, and anything that's a greeting, it's going to pull it in.
Only on the top level. Or if you had like nested greetings, would that work?
No, it's just at the top level there. So, or is it? Hold that thought. We'll come back and take a look at it. So for each of these greetings here, system.out oot println hello plus greeting. Oh,
Right there. The hello mark.
oh, is it? Oh, it's actually it got stripped off because we didn't hold it.
Hello's a keyword.
Hello's a keyword. It's not actually data. If we wanted to, I could say
Just saving.
hello equals that. So it only stores the name. So greeting.name. Something like that. So this is one way we can do it. That's going to print out all those. Let's put a separator in there. Let's say that we wanted them to all be comma separated. So then what I can do is say hello, and now we want to walk through them. So I'm going to say take all the greetings, and I'm going to convert from the greeting object into just the name. So I'm going to use the map function to say take in a greeting, return a name. So it's going to basically create a new list of just names. Keep in mind that it dot is optional there. So this is going to say for each of those greetings, convert it into a name. Or I could be explicit, like that. And it's going to convert each of the greetings in the list to just a list of names. Once I have that list of names, I'm going to do the join like they were doing before, which is going to take, I guess you can use the single quotes for spaces as well. It's just that it takes a single quote or a double quote for strings. So this should make them all be comma separated. Make sense so far? Okay. Yes. So it's just going to have, hello, A, comma, B, comma, C, exclamation mark. Okay, and let's see. What was the other way I was thinking of doing this? Something like this a little bit more directly. So another approach, instead of having this explicit for loop like this, and this is going to be this won't be too bad. I can say greetings for each. Is this how I want to do this? No, it'd be a map. So I can map using a gen method that's just going to generate things. That's going to convert it into a list of strings, which I can then join. Does it have a before and after, I think? Yeah, it says before, separator, and after. If you just use a single one, then it's a separator. So I'm going to separate them with new lines. So for this one, I can then say def gen, passing in a greeting. And there, I'm going to do this stuff. Actually, if I do it like this, I shouldn't need that separator, because this actually should have a new line in there. So this should say hello greeting name, and that should join them all together. So what I should get out of this is this map is saying run the gen function against each one of those greetings and give me the return value. That becomes the new list. Then for that new list, I'm going to join them all together with no separator. I think that's what this one's going to do. It might, maybe the default is a comma.
What have you joined them? What have you mapped to them? Nothing.
I've mapped them to this string value here. So this is going to say for each one of the greetings.
Oh, because
I'm going to have, it's going to be a list of this string,
type of thing.
and then join it. So this is a little bit cleaner in the overall class definition.
To print that one.
Well, it's actually the guillemot's here. It actually takes that string value of them all joined and just drops it in place. So if you had a whole bunch of loops that you wanted to walk through, it can be a little cleaner to do this and then reference them. This is a little bit more explicit and sometimes a little more readable. Just depends on what you prefer reading. Let's try this and just see how it works.
Yeah, I had forgotten to pull out the greeting at the top. So I was trying to.
Well, you could still do that, this whole chain down right here. That would still work. But it's a little grosser, especially if we're using it multiple times. So then up here, what's the file name on this? Is it greetings? Oh, my DSL, that was it. Okay, so we'll say new file craft.myDSL. Oh, no problem. Hello, Scott. Hello, Steve. Hello, Jello. And then let's see what that actually looks like. In our default package, we have greetings. Ooh, code gen, the first time it worked. How about that? So we're putting out the three separate ones, and then the comma separated. Make some sense? So that's a little bit more of a hello world, really basic code generation type thing there. Okay, so now we're going to get a little bit more interesting here. Huh? Oh, no, that's fine. I got plenty of time. I don't have a whole lot more for this session anyway. So what we're going to do is create a brand new project again. And I'm going to call this com.javadude.infer1. And do some of that.
What does that jar do again?
So the difference between a regular layout and a fat jar is when you have the code that gets generated for your project, that has a bunch of dependencies. So there's a bunch of third-party jars that need to live with it. The normal layout is that your jar will sit in a directory, and then you'll have a subdirectory next to it called libs, which has all the third-party jars in it. And then inside your manifest, you mention that the manifest for the jar, you say that this libs directory is my class path. Instead of that, because then you have to zip it all up to deliver it, a fat jar takes all those extra jars and sucks them into the main jar. And there's two ways to do that. One is that the jars themselves are a sublevel inside the jar. Another is that it extracts all those jars and then just puts the code directly in. And it depends. If somebody sealed a third-party jar, you can't do that. Otherwise, it won't work. The fat jar has basically a special launcher which knows how to set up a special class loader to load all those extra jars. So that way it's just one jar you have to deliver. Sometimes it's called a shadow jar as well. Okay, so what we're going to do in this is I'm going to use type inferencing on this. And they have this, or sorry, model inferencing. What this does is it allows me to, in my grammar, refer to Java type concepts. I can also refer to expressions which are provided by XBase, which is a good chunk of the extend language. So basically all the expressions that are in extend would be available in my grammar without me having to enter in a whole bunch of wonderful things. You guys are going to have to enter the wonderful things for your grammar, but this is something that if you really wanted a language that runs in the Java virtual machine and has access to Java functions, Java types, and all that, you can use this approach. What this also does is you create something called a model inferer. A model inferer. It's a hard word to say. And this maps your types in your grammar to actual Java types and the methods and the properties inside of those Java types. which then gives you the ability to reference them as normal Java classes inside your grammar. So it's a really nice, simple mapping way of doing things. It is problematic in doing in a Gradle build, though. So this is not something that I recommend you do. This is actually how I end up doing things for the current model generator that I have. And it's let me do some things very nicely, but I really regret not using the textual form because that would work better in Gradle. And I don't want to reconvert everything right now. So I'm stuck with my separate Eclipse over here, IntelliJ in a different window. So I'm going to take the grammar here. Let's go to the model version we had here. I'm going to copy most of his stuff. Just the rules into there. And then I want to make one big change at the top. Instead of saying with that, I'm going to reference the XBase stuff. So it's org eclipse xtext xbase. Xbase dot xbase. And this is going to give me the access to all of the expressions that I want to use. And when I have that and I run this MWE2, it's going to say, oh, he's using XBase. I want to generate an inferer for you. And so he'll generate the stub inferer that you can then extend. Inside here, whenever I have type references, instead of explicitly having all the type stuff, and if I had an explicit expression grammar, instead of having the explicit expression grammar, I'm just going to reference Java types. So I'm going to get rid of all this mess down here. Bang. And then where it says type here, it's going to be XJVM reference. Is that right? Or is it just JVM reference? JVM type reference. There we go. So that's going to let me reference any type that's defined in the Java virtual machine, including primitives. And what was the other one that I needed to change? Oh, I wanted to add in also the ability to have initializers. So I'm going to have as an option here, question mark, or init with, how about that? I couldn't just use equal, it has to be different. And then I'm going to have initializer equals X expression. And that's optional. Okay, so that's simplified the grammar quite a bit. You know, a lot of the stuff that is provided by XBase, I can take advantage of. And that also includes if you want to have like method bodies. And in the initializer, you can actually use lambdas as well. Okay, so we have all that defined. I'm going to go ahead and run MWE2. And now we'll see that. Oh, I ran the wrong one. I'm going to go to inferer. And so now we'll see that it created this JVM model package with infer DSL JVM model inferer.extend. So what this guy does is he has this infer method. They're going to walk through it kind of similar to what we saw in the validator, where it's going to call it for each type that you have defined. This is going to call infer, passing in the model envelopment. You could pass explicit the lower types if you wanted to. So let's say that you had a model with a bunch of classes. You could just start with infer class, and it'll just throw the class right in there. If you need the model for some reason, like we do in this case for the package name, then you want to do it from the top level like this. So we're going to pass that in. I'm going to change him to say model. And we're going to do something kind of like this little block of code that they have here to set up our classes. And let's see what I had done here. That's what I wanted. So I'm going to start by saying, let me grab the model. Let's get rid of all that cruft. I'm probably not going to need the JVM types builder, but I'm going to leave it there. So I'm going to say var model. And then inside here, We'll start with a this dot model equals model, and then we can have model dot for each. Oh, model dot classes. Man, can I spell? And then for each of the class, I'm going to generate it. I'm doing this right? Yeah, okay. So we'll say it dot infer, passing in the acceptor, and is pre-indexing. Depending on what you're doing, you might have to do something different when it's first making a first pass. It does 2 passes over your model. One to just get the type names, and then the second one to actually finish off. Pre-indexing is that first pass. So I'm going to come down here with a new def dispatch for class decal. And then inside there, I want to say for each of those class decals, let me map it to a real Java class. So I can say class decal dot, is it 2 class? Yeah, 2 class. And then we're going to pass in the qualified name of it. So the qualified name of the class is going to be model, oh man, dot package dot class decal dot name. Boom. And anything else I need in there? Super types or anything? No, that's all I need for there. So that's going to create an actual Java class that is mapped to this class that I have in my file. One of the nice things about this is it also generates, in Java, when you do code generation, you can generate a, what do they call it, a trace file? Yeah, there's a trace file that basically can map from your source to the actual bytecode. And if you have that trace file, it allows you in the debugger to actually walk through your original source as opposed to the generated Java source. Not always useful, but sometimes it is. I generated trace files for Antler a while back in Antler 2. Boy, that was hell. And so it lets you kind of step through your grammar as it's matching things. But it was really neat. I mean, it was a pain in the butt to generate to start with, but once I got the hang of it, it was a pretty neat effect. Now we can also have a lambda used to do initialization on this object. So you're following it up. Very similar to how in Kotlin, if your last argument is a lambda, you can have it be outside. I mean, it's stuff like this that makes me think the Kotlin people saw this language, because this is a lot older than Kotlin, and liked the concepts and took a lot of these concepts. But they came up with a lot nicer syntax, I think.
Not using square brackets.
Yeah, it's like, I mean, honestly, I'd almost rather go back to begin and end like you had in Pascal instead of having curly braces. It took me a while to get used to curly braces. So inside here now, I'm going to say that class, he has a list called members defined in it. I'm going to add in fields to that member list and function definitions to that member list. So I'm going to say members plus equals.
And this is using that implicit it.
Yes, exactly. So inside of this guy, I'm going to walk through the properties. Oops, class decal dot properties. And for each of those, I'm going to say p dot to field to start with, passing in the name of it, so p dot name, and then the type, p dot type. And if I have an initializer, I can pass that in as well. Oh, that's not how I do it. I thought you could do that. You can pass in a lambda to initialize. Oh, I'm sorry. It's the initializer for the field like this. There we go. I got to wake up. That's what it's that extra argument there. So now I can say if p.initializer, the one that we defined in the grammar, is not null, initializer equals p.initializer. And so that'll set up the field initialization. Now we might not need to have that null check. Note that it's a little picky about these guys, that if you're doing reference equality, you should use the double equal sign for not double equal, or triple equals if you're looking for equality. Kotlin's the same way, but it makes some better assumptions now. With null, you don't have to use the three equals. You can use just the two. I think I can just do this because I think that'll just set it to null. That should be fine. So it's going to create the field and set up the initializer. You can also do things like say, is it access? Private? So you could say static equals true if you want it to be a static field, things like that. There's a few little modifiers you can do on that. But we're just going to make it, we're going to let it be public, which is, or let the field be private, which is a default for toField. Is it visibility? Is that the one I'm thinking of? Yeah, so you could say visibility equals public, private, protected, whatever. By default, fields are private. And then I'm going to say members plus equals p.toGetter, passing in p.name. They have a couple special things just to create getters for you. p.type. And I don't need anything extra special in there. And I could say p.toSetter, just like that. And I believe I'm done. Yeah, that looks good. Let's go ahead and am I running my nested? Nope. Let me run my nested. Okay, so inside here, so why is that not coloring? What did I have for my, oh, did I not change the type in that guy? The extension? Model infer, okay. That was what it was. There we go. Oh, I didn't do the imports. That's what I missed. Let's come back over here and fix him up. And what did that look like? Import section is X-import section. So the import section name is treated specially in the grammar so that it knows that you're trying to deal with imports, and it can actually, when you reference a type, it can automatically pull that in. So let me regenerate. Run as MWT workflow. Okay, and yeah, definitely. This is so much faster than that Surface Book was. Okay, now person. Why is it not liking that? Let me take a look at this again real quick. So model.package, class decal.name. That should be okay. So why is it not seeing those types? Because they're not getting generated. That's why it's not seeing those types. And why are they not being... Oh, no. Let's see what's going on here. So it's going inside there. So I've got the package.
XYZ versus ABC.
Yeah, it should be an XYZ package showing up here. That worked for me when I did this before. And then you shouldn't need to explicitly import these guys. Oh. It looks like it's going through the right motions. Let me try breaking here and taking a look at model package. Make sure that looks like that's coming up okay. Oh, wait a second. No, that looks okay. Huh. It's worked fine this morning. Okay, so let's come back over to here. Oh, to there. And let's take a look at model package x.y.z. Oh, duh. Okay. I see what the problem is. Let's come back out here, kill him for a second. Okay, so what I forgot to do here, oh, go back to my Java perspective, is I'm creating a class declaration, but I didn't tell the acceptor to accept it. So I have to add it to the acceptor so that the acceptor knows what it's going to be generating. So I think it's just acceptor.accept, right? Yep, okay. Now it's going to work. So now I'll run my Eclipse here. Kill my breakpoints. And now we should see XYZ. There we go. And if we take a look at person, he looks fairly similar. He's just got the getters and setters. I don't have the Java Bean property stuff inside there, but this is the basic support that it gives you for free. Okay, and he adds in a suppress warnings all, so that in the generated code, if there's any warnings, you won't have to see those cluttering up your workspace. Something to be careful about. Now, one thing that you may want to just note in code generation in general, when you do imports like these, sometimes it's a better idea to everywhere you reference something like list here to fully qualify it. So you have java.util.list every single spot you use it. That way, if any code that you generate conflicts with what the user specifies in their imports, you won't have a problem with it. Sometimes that's really useful, and it's in the generated code, so it's not terribly ugly to fully qualify everything. Another thing to be careful of here. In our previous example, the model one here, notice that I hard-coded this regardless if I needed it or not. So my choice here was to either fully qualify it every place I use it, or stick it up here hard-coded, or I could come up with a scheme to say, if I've used it at all, put it up here at the top. And the way I typically do that is to keep track of some kind of a mapping of, or some kind of a list of all the imports that I've used. So imports needed equals new hash map string string, and then generate a little method. I'll just call it I for a string fully qualified name. And inside here, I'll say imports needed. Actually, I just make that a set. Add fully qualified name. And then I can say return fully qualified name dot substring fully qualified name dot last index of dot something like that. So what this does is any place I would refer to an import, a fully qualified name, I'd put the I on it. And I usually say if there's some common things that I use, I'll explicitly list them, like I list equals I of java.util.list. Oh, not equals. What am I doing? Kotlin? Something like that. And so instead of having that import, anytime I have a list, I would instead say iList. Just like that. Do I need the parens on that? I might not need the parens. We'll find out. And so this will put it in my import list. But in order for that to work, I need to split up my actual class generation into two parts. The body of the class, which is going to be filling in that import list, and then something that wraps around it that adds in the package and the imports. So I do something kind of like this. Top level class decal is just the package, and then those imports, what do I call it? Imports needed? And then the body. Although I need to reset those imports somewhere. Oh, that actually goes outside this. So then this guy has the body we're generating there. And here's where we're actually generating everything. So at each point in here, I'll say imports needed clear to start with. We're going to generate the file, and instead of just class gen, I'm going to put a gen around it. How's that for obvious enough? Really? Yes, you can convert from a character sequence to a string. So I'm basically wrapping the body with this extra little stuff at the top.
Oh, sorry, I saw those two streamlined.
So that should take care of that. And we can do the same kind of thing here.
So you need to add the I around your property, whatever.
Property change support, yep. So all that looks good there. Where's my other I's there? Let's do the I PCS java.beans. property change support IPCL property change listener. And in the inferrer, it already has an import manager to take care of this for you. Is there anything else I needed, or just those ones? So then this guy is going to be IPCS. Let me just make sure I don't need the parens. I'm pretty sure I don't there. What did I do with that dot? Oh, I had the index. I need to put a +1 on that index. Okay, so it pulls in the property change support appropriately, and it added the import up there, which is good. So I just need to fix the other ones up. So him. Oh, it's actually the property change listener now. So IPCL. There. String builder's in Java Lang, so that should be okay. That all looks good. I think that's it. There we go. So that's the type of thing you'd want to do to take care of these imports if you wanted to set it up so that you only have the imports exactly that you needed. Otherwise, if somebody had a class that didn't use a list, for example, you'd get a warning coming out of it. So you can do that, or alternatively, everywhere you reference it, fully qualify it. That's your other option there. Just it's kind of a matter of taste either way, something like that. Let's see, was there something else I wanted to say on the inferrer? So this added in the new array list and 42 for those guys. So if I save him, oh, what happened to my factory here? Oops. Factory okay now? Why am I importing those? Ah, yes. Thank you. I forgot to clear them. That would definitely make the difference. And so we'll go to the model, generate him. There we go, that's better. And now, in the inferrer, we see that the initializer took effect there. You can also have operations, they call them, which are functions. And then in your inferencing, you would have a members plus equals, let's say class decal to method. So you can have an explicit method for an operation. Let's say we added a toString there. And, oops. And we need the type of him, right? So it was type of string.class. I think that's how you do it. Use this type. Oh, I can't remember what that looked like. Type ref. That's it, type ref. And then inside there, we can have any arguments we need to pass in. So you could say parameters plus equals something. Or if you want, you can also have a body. If we referenced a JVM operation in the grammar, you could just say body equals whatever that operation is. Otherwise, you can just specify the body explicitly here. Something like that. And so now, if I come over here, bless you. Do-do-do-do-do-do-do-do-do. Now we see that we got our toString returning that body. And I could have the body generated the same way I did before if I wanted to. Make some sense? So the real power of this inferencing approach works when you start actually having functions with some data inside of it, or in the form thing that I did. I don't have that here. In the form generation stuff, I had the definition of a form for Android, and then things for how to get the data and how to set the data, which were little bodies specified in XBase. That was nice because then it takes that XBase code, generates Java code for the body of the actual functions that you're working with. But unfortunately, this has a few wrinkles as far as using it in Gradle. So I really recommend that you look at using the text approach to actually doing any real work. Okay, speaking of real work, assignment, which is not real work. This assignment, I'm going to write it up tonight. I just haven't had a chance to write it up yet. Very simple idea. What you're going to do is take what you did in Antler, convert it to xtext for the grammar. Note that you'll need to do all the removal of the left recursion, like we talked about last week, where you're going to have the rules that contain other rules for the expressions. And then I want you to write a code generator, which is going to just have a class you generate with a main. The main is going to create your GUI and show your GUI. Make sense? So should be pretty straightforward. I mean, it's a different language, a different way of doing things. But I want you guys to get the hang of what this might be useful for. The big bang of this is that this is basically the second time you generate something. So the first time you generate things, it's a little more work to set all the generators up to start with. But then when you want to go and make a small change, like making properties be observable, change it a couple lines in your generator, and then you can get thousands of lines generated from it. The project I'm working on right now, it's about 100,000 lines of code. 40,000 of that is the code that I write by hand. The other 60,000 are generated. And that's huge. I mean, I absolutely love it when I can take advantage of stuff like that. There's some of it I'm converting over to Kotlin so I can use internal DSLs instead of external DSLs. And the DSL is almost identical to what I wrote externally. So it's not a huge shift there. But it's still, the code generation has done me so much benefit. And getting a lot of very consistent stuff, make a couple tweaks, and boom, you have a brand new set of data. Okay, any questions?
This is another 2-week.
Yes, this will be a 2-week assignment.
And are we going to do another one? Because we got, 4 more weeks, right?
I think so. Yeah, there should be one more assignment. I'm not sure what I want to have you do yet. I'm not quite sure what the rest of the class is yet. I've got a bunch of ideas. I just, ferreting down to the topics that I want to cover. And if you guys have any specific topics you'd be interested in that seem to fit with the course, let me know. That might help me choose which ones I want to include, because I obviously can't cover everything in the world. But the more I can touch on to give you ideas about these are different techniques you can use for your programs, it's like that's really what this class is about, is exposing you to stuff that you may not have ever seen otherwise. Okay, yes?
Do you prefer if we use the infer method versus the
Use the text method for this.
text method?
Yeah. The inferencing one you could use, it's a bit of a bear at times.
Well, that's what I was looking at. It would be easier if we could just lay it out and just put it in.
In some ways, yes. In other ways, the inferencing is a little easier. The nice thing about the inferencing is you don't need to specify as much in your grammar. Because you can just say, I'm going to use XBase. Although the grammar doesn't look the same as what we're doing anyway. But all the expression type stuff, it's like, you could do that in XBase and it would cost you nothing. and you'd get a whole bunch of extra support. And on top of that, any Java method you want to call. So I mean, there's a huge benefit to doing that. But I basically want you to take the same grammar you have and then use it in Xtext, and then use the text generation, the big template thing to generate your code.
So are we also doing validation for this as well?
Yeah. So
So we have to convert the Kotlin stuff that you wrote
Mhm.
to
To-
extend.
well, not extend. Well, depending on which one it is.
It would be the Java.
It would be to Java if it's at runtime. I'm going to still try to see if I can get a couple quick examples working to have it use an IntelliJ as well. If I can do that, no, I'm not going to have time, unfortunately. I was going to say if I can do that quickly enough, I can send it to you guys, and if you want, you can just directly use that Kotlin stuff. It shouldn't be too hard to convert it back to Java, though. Any other questions? Yeah, because eventually I'd like to have this be where you can just generate Java code and do it inside there. But getting that to work in Gradle has just been a nightmare. And I've been trying that for a while because I really want to get that. I'd love to have everything just have one build instead of building the plugins, then building the model, then coming over here and doing stuff in Eclipse or in IntelliJ, then coming back because now there's references over here that have changed, and it's like, it's just gross. Okay, any other questions? Okay, I will get the assignment write-up. The assignment write-up is just going to be a paragraph, basically. Do what you did in Xtext. And if you have any questions, give me a yell. But yeah, it should do the same validation. It should do the creating the GUI and putting up on the screen. The end result should end up looking the same. Okay, have a great week.